you to record. You can today's session and that session also. Okay, so we were doing intermolecular hydrogen bonding. Intermolecular hydrogen bonding arises when there are two molecules and hydrogen goes and forms a bond mostly with fluorine, oxygen, or nitrogen. Okay, so in certain special cases, carbon and chlorine also forms hydrogen bonds. So we have to discuss about those cases today. But before that, let's quickly revise some examples that we had done in intermolecular hydrogen bonding. The first one was HF, second one was water, third one was alcohol, and the fourth, which is a very important example, that is of para-nitrophenol. So para-nitrophenol has intermolecular hydrogen bonding. Now there are a couple of more examples in intermolecular hydrogen bonding. Let's talk about acetic acid. Okay, we have to talk about acetic acid. So you know what is the structure of acetic acid, madam?
No.
Acetic acid, CH3COOH. The IUPAC name of this acid is called as the IUPAC name. You know what is the IUPAC name of this acid? Can you tell? The IUPAC name of this acid is ethanoic acid. Okay, it's a carboxylic acid. Okay, so how are we going to show hydrogen bond over here? Let's see out. Let's see what happens over here. We will have a C double bond O like this. Okay, and just 1 minute. It's like this, CH3. Then you have a C double bond O, and then you have O dash H. Similarly, you will make another carboxylic acid, C double bond O and CH. So where is the hydrogen bond over here? The hydrogen bond is over here. See, this is the hydrogen bond. So basically, acetic acid in vapor phase, okay? Acetic acid in vapor phase, it is going to form a dimer. So what is the meaning of a dimer? Dimer means two molecules are going to be joined. So there are two molecules of acetic acid which gets joined, and they had asked once the molar mass of acetic acid in vapor phase is. So actually the molar mass of acetic acid is 60, but since it forms a dimer, its molar mass gets doubled and it is 120. So remember this, if they ask the molar mass of acetic acid in vapor phase, you have to double. In vapor phase, it forms a dimer. Got it? Now the next example is of KHCO3.
Sir, can I
KH,
write this down?
yeah, sure.
Done, sir.
Done? Okay. Now the next example that we have to do is of KHCO3, which is called potassium carbonate. KHCO3. तो इसका जो अनायन रहेगा वो हाइड्रोजन बॉन्ड बनाता है, वो डाइमर बनता है. तो इट विल बी लाइक HCO3. तो यू विल से HCO3 ऐसा रहेगा, C double bond O है. Okay, and then you have one OH and you will have O minus. Okay, similarly you will have OH like this. You will have C double bond O and you will have O minus. So where is the hydrogen bond? See, here is the hydrogen bond like this. So again it forms a dimer. Okay, this also forms a diamond. Anion of potassium carbonate, potassium hydrogen carbonate, okay, KHCO3, it forms a diamond. But if I take NaHCO3, which is called sodium bicarbonate or sodium hydrogen carbonate, it will form a polymer. Okay, it is going to form a polymer. So it will form a polymer like this. See, you will have HO, you will have C double bond O, and then you will have O minus. So H, C double bond O minus. H, C double bond O minus. So where is the hydrogen bond? See, this is the hydrogen bond. Okay. C double bond O minus. Uh, this one. OH. OH. Okay, my mistake. I made a mistake. I made acetate ion. So it will be H, then O, then C double bond O minus. H, O, C double bond O minus. Like this. See. So here there is a hydrogen bond. So this is going to form a polymer. Sodium bicarbonate will form a polymer, whereas potassium bicarbonate will form a diamond. आपको समझ रहा है मैडम?
Yes, sir.
ओके, नेक्स्ट वाला देखो, ये भी मस्त है. इट इज H3BO3. H3BO3, इट इज कॉल्ड एज ऑर्थोबोरिक एसिड. तो इसमें भी हाइड्रोजन बॉन्ड होगा, इंटरमोलिकुलर हाइड्रोजन बॉन्ड होगा. कैसे? यू विल हैव B at the center. You have B at the center like this. Then you will have O. Then you will have O and H. O and H. And you will have OH like this. Okay. So where will be the hydrogen bond? See, here there will be a one hydrogen bond. Here there will be another hydrogen bond. Here there will be hydrogen bond. Here there will be a hydrogen bond. Here there will be a hydrogen bond. Here there will be a hydrogen bond. Okay. Now remember this, the hybridization of boron is sp2 over here, whereas that for oxygen will be sp3. याद है हमने हाइब्रिडाइजेशन किया था, sp2 sp3 dsp2 वगैरह सब. So boron is sp2 and oxygen is sp3. Okay. Now the next example that we have to do is of water molecule. So water molecule we have already done, but that was in liquid phase. Now this water molecule will be present in a solid phase. That is, I'm talking about ice. So water molecule जब hydrogen bond बनाता है, it has different coordination numbers in liquid as and in solid form. In liquid form it was 2. You can see this. See, this is the liquid form wala water molecule. So 2 hydrogen bonds in a linear direction. But when we talk about water in a ice form, तो सी यहाँ पे water ऐसा रहेगा. Okay, where will be the hydrogen bond? Here first bond, here second bond, here third bond, and here fourth bond. So there will be 4 hydrogen bonds over here, and there will be some void space over here. See, this is the void space, and this void space is basically called as a cage-like structure. This is called as a cage-like structure. So that is the reason why the density of ice is less than water and it floats on water, because there are a lot of void spaces. Okay. Got it, madam? Now we have to, so these are the examples. Have you copied down?
1 second. I have to copy.
Yeah, sure.
Can you scroll up, sir?
Yes, madam. This one?
Hmm.
Okay.
Done, sir.
Done? Okay. So now we have to talk about intramolecular hydrogen bonding. Now, what happens in a intramolecular hydrogen bonding is there will be a hydrogen bond within the molecule. Okay, within the same molecule, you are going to have a hydrogen bond. हम intermolecular hydrogen bonding में क्या कर रहे थे? We used to make a hydrogen bond between two molecules. But in intramolecular H bonding, we'll have only one molecule, and within the same molecule, you are going to have a hydrogen bond. Okay, and this intramolecular hydrogen bonding, it causes chelation. Now, the meaning of chelation is it will form a ring-like structure. Ring बनाता है वो. It forms chelation. Okay, so let's do this. Very simple. Suppose the first example that I want to give you is orthonitrophenol. See, orthonitrophenol will be something like this. And this was asked in very recent NEET paper. It was asked in 2024 NEET paper. See, ये compound जो है, ये वाला जो compound, it forms intramolecular hydrogen bonding. देखो ये वाला जो है, this hydrogen goes and forms a bond with O minus. So this is called intramolecular hydrogen bonding. What is the name of this compound? This compound is called orthonitrophenol. So orthonitrophenol is going to form intramolecular hydrogen bonding. Then there is one more example, this one. See this one. This is like a orthosalicylaldehyde. So this also forms a hydrogen bond. Like orthosalicylaldehyde. Okay. Then there is one more. This one. See. Then C double bond O OH. So this also forms intramolecular hydrogen bonding. See, hydrogen goes and forms a bond with very high electronegative atom like fluorine, oxygen, or nitrogen. And this compound is called orthosalicylic acid. Okay. Then anion of malic acid भी हाइड्रोजन बॉन्ड बनाता है. So let me draw that. This is the fourth example. Three examples I have already given you. This three examples: orthonitrophenol, orthosalicylaldehyde, orthosalicylic acid. Now the next one is anion of malic acid. तो मैलिक एसिड दिखता कैसा है? ऐसा है, CH डबल बॉन्ड CH COOH COOH. बराबर. तो अनायन बोल दिया तो O माइनस रहेगा, और ये O माइनस अभी क्या करेगा? हाइड्रोजन बॉन्ड बनाएगा, दिस हाइड्रोजन. तो दिस इज कॉल्ड अनायन ऑफ मैलिक एसिड. अनायन मतलब नेगेटिव चार्ज. दिस इज अनायन ऑफ मैलिक एसिड, एंड दिस इज लाइक cis form. Cis मतलब the similar groups will be on same side of the double bond, having an angle of 90 degree between them. Okay. Then we have anion of Carros acid. So Carros acid is H2SO5 होता है, H2SO5. तो ऐसा कुछ बना दो, S double bond O, S double bond O, then O dash H, the O dash O माइनस. तो यहाँ पे हाइड्रोजन बॉन्ड बनेगा. व्हाट इज दिस कॉल्ड एज? अनायन ऑफ कैरोज एसिड. अनायन ऑफ कैरोज एसिड. गया दिमाग में मैडम? ओके.
Yes.
ओके.
1 second, sir. I have to write.
यस यस.
Turn, sir.
ओके. नेक्स्ट अभी हम जो करेंगे वो कुछ स्पेशल केसेस है. मैंने बोला ना, कार्बन और क्लोरीन भी तो बनाता है हाइड्रोजन बॉन्ड. Carbon and chlorine also forms a hydrogen bond. So these are those special cases where carbon and chlorine will also form a bond. So first is acetylene and acetone. Acetylene or acetone. So acetylene and acetone. So acetylene will be like this: H C triple bond CH. Okay. And acetone will be this. तो यहाँ पे भी हाइड्रोजन बॉन्ड बनता है ऐसा. सेकेंड वाला जो है वो है क्लोरोफॉर्म एंड एसीटोन. क्लोरोफॉर्म एंड एसीटोन. क्लोरोफॉर्म एंड एसीटोन. सो क्लोरोफॉर्म का स्ट्रक्चर क्या होता है? ऐसा रहेगा, सी एंड एसीटोन. ऐसा रहेगा, क्लोरोफॉर्म एंड एसीटोन। ठीक है, तो यहाँ पे भी हाइड्रोजन बॉन्ड लग जाता है। फिर और भी दो एग्जांपल्स है इसके, मतलब व्हाई दिस आर स्पेशल केसेस। सी, मैं आपको है ना हाईलाइट करके बताता हूँ व्हाई दे आर कॉल्ड स्पेशल केसेस, बिकॉज अभी देखो ये हाइड्रोजन बॉन्ड है और ये वाला भी हाइड्रोजन बॉन्ड है। तो मुझे बताओ यहाँ पर हाइड्रोजन के एक बाजू कौन है? हाइड्रोजन के हाइड्रोजन के वन साइड ऊपर वाले देखो, यहाँ पे हाइड्रोजन के वन साइड कौन है? कार्बन है, और एक साइड ऑक्सीजन है, दिख रहा है? सिमिलरली ओवर हियर हाइड्रोजन वन साइड इज कार्बन, वन साइड इज ऑक्सीजन। एक्चुअली इन हाइड्रोजन बॉन्ड बोथ द साइड्स ऑफ हाइड्रोजन शुड बी आइदर फ्लोरीन ऑक्सीजन और नाइट्रोजन। दिख रहा है? देखो ये रहा, इट शुड बी आइदर फ्लोरीन ऑक्सीजन और नाइट्रोजन। बट दिस आर स्पेशल केसेस वेयर द साइड एटम्स अदर, मतलब टू विथ रिस्पेक्ट टू हाइड्रोजन is carbon, but still it forms a hydrogen bond, and that is the reason why it is considered as a unique case. Okay, and then you have one more example, that is orthochlorophenol. So orthochlorophenol will look something like this. You will have OH group, and then you will have chlorine, and there will be a hydrogen bond like this. Got it? So this is orthochlorophenol. And next, last example is chloral hydrate. It's called chloral hydrate. So chloral hydrate is like CCl3, like this, CHO. Okay. यहाँ पे रहता है देख, ये हाइड्रोजन बॉन्ड ऐसा, ये हाइड्रोजन बॉन्ड ऐसा। गॉट इट? तो ये भी आपको याद रखना है, ठीक है? Then what you need to know is strength of hydrogen bond. तो हाइड्रोजन बॉन्ड में आपको सिर्फ ये याद रखना है, सी इफ दिस इज द हाइड्रोजन बॉन्ड, if this is the hydrogen bond, atom A and B. So if A and B are fluorine, then it is the strongest hydrogen bond. Okay, and A has to be, if they both are not fluorine, if A and B both are not fluorine, then A has to be oxygen and B has to be nitrogen for a stronger hydrogen bond. Now they say that the strongest hydrogen bond is seen in KHF2. KHF2. So how does this look like? It will be K plus, F minus, and there will be a hydrogen bond over here, like this. So what are the different types of bonds that are present over here? So the bond between K plus and F minus will be an ionic bond. Okay, it will be an ionic bond. तो वो मैं लिख देता हूँ. It will be an ionic bond. So ionic bond is present. Then a hydrogen bond is also present. between F minus and H, and between H and S, it is a covalent bond. Got it? So this is the most strongest hydrogen bond, KHF2. Now we need to learn the applications of this inter and intramolecular hydrogen bonding. So what applications are there? So let me write down that applications over here. And this part is very important. So wherever you are writing this, just mark it important. They are applications of H bonding. ओके, तो हाइड्रोजन बॉन्ड जो है, तो यहाँ पे मैं प्रॉपर्टीज लिख दूंगा, प्रॉपर्टीज, देन यूर विल राइट इंटरमोलिक्यूलर and intra. So what effect hydrogen bonding has on, say, boiling point, then a melting point, okay, then solubility, and vapor pressure. VP stands for vapor pressure, okay. So now they say that due to hydrogen bonding, due to intermolecular hydrogen bonding, the boiling point increases. Due to intramolecular, it decreases. Okay. Melting point also increases in intra, it decreases. Solubility increases in inter, due to intra, it decreases. Now, vapor pressure, इंटरमोलिकुलर हाइड्रोजन बॉन्डिंग की वजह से कम हो जाएगा, इंट्रामोलिकुलर बॉन्डिंग की वजह से बढ़ जाएगा. And why such a thing is observed? Because you will say that ये जो boiling point होता है ना, boiling point, so that is directly proportional to association जो intermolecular hydrogen bonding में होता है. ओके, जो melting point होता है, melting point, so that is directly proportional to CFE, that is crystal field energy. तो वो intermolecular में ज्यादा होगा. जो solubility होता है, solubility, so again that is directly proportional to association. तो इंटर में एसोसिएशन ज्यादा होता है, तो बॉइलिंग पॉइंट भी बढ़िया आएगा. पर जो वेपर प्रेशर होता है, रिमेंबर दिस, जो वेपर प्रेशर होता है ना, so that is inversely proportional to boiling point. So more the boiling point, less will be the vapor pressure. So you can see that the boiling point of intermolecular hydrogen bonding is more, so its vapor pressure will be less. And similarly, for intramolecular, the boiling point is less, so its vapor pressure will be more. ठीक है, तो ये हमें पता होना चाहिए. तो just note it down. ठीक है, let me know once it is done.
Done, sir.
Done, na?
Hmm.
Okay. So now they say that we have to do certain questions based on this. So they say that boiling point of ऑर्थो, मतलब पहले पैरा लिख लेते, बॉइलिंग पॉइंट ऑफ पैरा नाइट्रोफिनॉल is greater than that of ओ नाइट्रोफिनॉल, क्या रीजन है इसका, बता सकते हो आप? वाई पैरानाइट्रोफिनॉल हैज मोर बॉइलिंग पॉइंट? बिकॉज देखो पैरानाइट्रोफिनॉल में क्या होता है, पैरानाइट्रोफिनॉल में एसोसिएशन होता है ना, ये देखो दिखा है ना यहाँ पे। और पैरानाइट्रोफिनॉल में देखो बॉइलिंग पॉइंट बढ़ जाएगा क्योंकि उसमें इंटरमोलिकुलर हाइड्रोजन बॉन्डिंग होता है। तो आप यहाँ पे ये रीजन लिख सकते हो कि यहाँ पे इंटरमोलिकुलर हाइड्रोजन बॉन्डिंग होता है, और ऑर्थोनाइट्रोफिनॉल में इंट्रामोलिकुलर होता है। देखो ऊपर आज ही हमने किया, कैन यू सी ऑर्थोनाइट्रोफिनॉल, देख सकते हो आप, ये रहा, ये वाला ऑर्थोनाइट्रोफिनॉल, उसमें इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग हो रहा है। तो इंट्रामोलिकुलर हाइड्रोजन बॉन्डिंग की वजह से उनका बॉइलिंग पॉइंट कम हो जाता है। देन द सेकेंड एप्लीकेशन दैट वी नीड टू नो इज कि जो बॉइलिंग पॉइंट है वो ऑर्थो salicylic acid is less than that of parasalicylic acid. ओके, तो यहाँ पे ऑर्थो में क्या होता है, इंट्रा होता है, और यहाँ पे इंटर होता है, तो पैरा में ज्यादा होगा बॉइलिंग पॉइंट। ओके, then why do ice floats on water? Ice floats on water because of cage like structure. It forms four hydrogen bonds, and there are a lot of void spaces over there. Then the next is, they will tell you that boiling point of say, can you name the alcohol in IUPAC maybe? अल्कोहल का IUPAC नेम बताओ। Hmm? Not, we are not, we were discussing solubility, okay? Solubility, not boiling point. ये देखो ना कितने कार्बन एटम्स है मैडम, देखो ये दिस इज 1 2 3 4 5 6 7 हेप्टेनॉन, और ये 1 2 3 4 ब्यूटेनॉल। सो दे विल से दैट ब्यूटेनॉल का बॉइलिंग पॉइंट ज्यादा, सॉरी ब्यूटेनॉल का solubility विल बी मोर, because solubility is inversely proportional to hydrocarbon chain. This hydrocarbon chain, na, this hydrocarbon chain, it is called hydrophobic. It is hydrophobic in nature. Hydrophobic matlab they run away from water. So more the number of hydrophobic chain, less will be the solubility. Got it? ये
Yes,
समझा आपको मैडम?
yes.
ओके, 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 ओके। तो
So
ये
once
ये
again,
हमें,
right.
हाँ हाँ प्लीज राइट इट डाउन।
Can you scroll up so a little bit? Can you scroll down? So,
Yes.
done, sir.
So now we have to do certain smaller topics, like one of the topics that we have to do. I'm writing it down over here. It is called Drago's rule. Okay, these are non-NCRT topics. They are not present in NCRT, but still we need to know them. And it's a very simple rule which says that if the central atom is belonging to third period and beyond it, and the electronegativity of side atom is 2.1 or less than that. So when does this Drago's rule gets triggered? It gets triggered when you have central atom, which is of period 3 and beyond. Okay, and the side atom electronegativity is 2.1 or less than that. That is, it means hydrogen. So then it says that then central atom, see, CH stands for central atom, does not go for hybridization. Does not go for hybridization. It will not go for hybridization. ठीक है, तो ये हमें पता होना चाहिए. तो इसके एग्जांपल्स देखो. देखो एग्जांपल्स में मैं आपको ये वाला दे देता हूँ. यू हैव PH3 फॉस्फोरस, नॉट फॉस्फोरस, पहले NH3 होगा ना. So you have NH3. Just join on the same link once the meeting ends. Then you have PH3, nitrogen, phosphorus, arsenic, antimony, and bismuth. So the bond angle decreases. Okay. The bond angle for ammonia is around about 107 degree and 18 minutes. And for rest of them, it is close to 90 degree. मतलब 94, 93, 92, 91 ऐसा